In this video, we'll cover the problem max area of island. In this problem, we're given a 2D grid of zeros and ones, where ones represent land, like this. This would be a section of land, and then zeros represent water, and we need to find the maximum area of an island in our input grid. We've seen this kind of question before, and we've seen the same exact question before using a BFS, a breadth first search, but today we'll use it using we will solve it using a depth first search, a DFS. I'm not going to spend too much time talking through the approach to the solution because we've seen the idea so many times. But the basic idea is this. We are going to iterate over the entire matrix, and every time we hit an unvisited one, we are going to initiate a search, in our case a depth first search, to traverse the entire island. So that would look something like this, or like this, or like this, or like this. I should have mentioned, the way we define an island is a group of ones that are connected going up, down, left, and right. We do not count diagonal connections. Anyway, so we will initiate our search. In this case, we want to count the size of that island, and then we're just going to compare that against some max variable. The key is that we'll use our depth first search traversal technique to get the size of the island. So I'll just write out this pseudocode here. And if this was a little bit too quick or you couldn't fully understand, I encourage you to check out some of the other videos. There are 2 other videos on number of islands and 1 video on max area of island. I spend more time on the concept behind this solution in those videos. So here we'll iterate over matrix and we'll say if we get an unvisited one, then unvisited one, then what do we want to do? We want to DFS to count to get island size, and the rest from there is pretty intuitive. You just want to keep a max variable, so I won't write that out. One important question is, how do we track what we have visited before? And as we've discussed, there are 2 ways we can handle this. Number one, well actually there's several ways, but there are 2 ways that we've discussed. Number one is to create a separate matrix called our visited matrix that contains booleans. And so like the position 0, 0 in our visited matrix tells us whether 0, 0 in the initial input grid has been visited. Or if we're allowed to modify the input, we can just change these values to zeros as we traverse them, because we'll never need to traverse them again. In an interview, you want to make sure to check with your interviewer and ask if it's okay to modify the input. Sometimes it isn't, and if that's the case, then you should go with the visited matrix solution or another solution. Okay, let's talk about the complexity of this solution. So the very first thing we always want to do with our complexity is define our variables. So let's say R is going to be the number of rows in our matrix, and C is going to be the number of columns in our matrix. So our time complexity is going to be O of R times C, because we are iterating over the entire matrix. This alone is R times C, but we also know that our DFS, in the worst case scenario, if everything was a 1, our DFS would go through the entire matrix once we hit like 0, 0, and then we would just skip every point after that. Another way to think about that is in the worst case scenario, we touch every point in this matrix exactly twice. It can never be more than that. So it would be 2 times, our complexity would be like O of 2 times the number of elements in our matrix, which is 2 times R times C, and we know that we can draw constants with complexity. So it's just R times C. In terms of our space complexity, so this depends on what solution we use. If we create a visited matrix, that's just going to be O of R times C space. In our case, for this question, just to keep things different, we're going to be switching the zeros to ones and modifying the input. So the maximum complexity or space complexity we use is determined by our DFS. So the question of what is the maximum size of our stack at any point in time? And you can imagine, assume we have a bunch of ones. If we're on this node, or maybe let's say we're on this node, we can go put this one on the stack and this one on the stack and this one on the stack and a bunch vertically on the stack. Or the same thing can happen horizontally. So our space complexity is going to be the max of the number of rows and columns. Whichever one is larger is telling us the worst case scenario space complexity. All right, that's all for the approach. So let's go ahead and switch over to the implementation. Now, let's see an example of how to solve this question in JavaScript. To get us started, I have our input matrix right here. I have the skeleton of our function, and then we're just printing out our function invoked with this input here. So our strategy is, first of all, iterate over the entire matrix. So let's do that. We're going to get the number of rows, which is going to be grid.length, and we're going to get the number of columns, which is going to be grid at 0 length. Now there is that edge case, which is what if grid at 0 is not defined. So we'll just handle that right here and just say if num rows is 0, let's just go ahead and return 0 because the max island area is just 0 because there are no islands. Now we know we want to iterate over our entire grid, so we're going to do something like this, and the same thing for our columns. And we also want to make sure that we have a value to return in the end. So let's say max island area is going to be initially 0, and of course we'll update it inside of our loop. And then in the end, let's just go ahead and return max island area. Inside of the loop, what do we want to do? Well, we determined that the way we're going to solve this question is we're going to initiate a DFS every time we find an unvisited one. The way we decided to track what's been visited is anything that's been visited is just going to be switched to a 0, which means if we ever find a 1, it has not been visited. So what we'll do is we'll say, let's grab the current value, is going to be grid at row at call. And we'll just say if the current value is a 0, then we know it's either was a 0, in which case it couldn't be an island, or it's an island that's already been visited. In either case, we don't want to count it. Otherwise, if we know that it's 1, we want to say current island area is going to be get island area. This will be a function we'll write. And we'll put some parameters here in a little bit. Or sorry, some arguments here in a little bit. And what we can do is we can say max island area is going to equal the maximum of whatever it currently is and this new island area. If this is confusing to you, it's kind of like the same thing as saying if current island area is greater than max island area, then set max island area to equal current island area. If you've done this kind of thing before, this is just a shorter way to do the same thing. You just update this variable to be the max of what it already is and your new value. Okay. Now, let's write this function get island area. So, get island area. What are we going to need to take in? We'll definitely need the grid, we'll need the row, and the column of the current position. Let's do current row. I've been writing out the word current, so let's be consistent. So current row and a current column. And let's pass those here before I forget. So we'll pass grid, we'll pass row and column. Now what we want to do is basically use a DFS to count the size of this entire island. So we're going to have our stack. And we know in the end we want to return an island area. So let's get current island area is going to be a variable that will be 0. And let's make sure we return that in the end. We also, let's put this at the top. We also know that we need to put something like our initial value on the stack. So what I'm going to do is make every element on our stack be an array containing the row and the column. We've seen this many times before, but mainly the idea is that we need 2 pieces of information to identify any location. We need the row and the column, so I'm grouping them in this array here. All right, now we'll say so long as the stack length is greater than 0, continue onwards. Now what do we want to do here? We want to pull off the stack, or pop off the stack. So let's say, let's do row and column is going to equal stack.pop. This is some destructuring. If you haven't seen this before, actually hold on. I'm going to change something first. I named these current row and current column. I don't like that. I would rather name these current row and current column. Instead, I'm going to name these start row and start column. And what I just did here is in VS Code, if you have 2 things that say the same thing, you can highlight one of them and then press Command D and then change multiple of them at the same time. You can do this with more than 2 things as well, so it's a nice shortcut. Okay, so here I'll name this current row and I'll name this current column. And if you haven't seen destructuring before, it's the same as if we did something like this. I've been writing out current, so I want to still be consistent, so we'll do this. But this is the same as if we said like current position equals stack dot pop. But we know that each element in the stack is an array with 2 positions. So we want to do const current row is going to equal current position at 0. And then column is going to be like the same thing. So this is just another way to write the exact same thing. You don't have to use destructuring. It's just a little bit shorter, so if you're comfortable with it, you can. If not, it's not a big deal. Let me be clear. This one on line 17 is current column. Okay. Anyway, so we've got access to our current row and our current column. Now we need to process the node, which as we know, that's the part that usually changes, so we'll come back to it. But we also want to go in all 4 directions. So we want to take current row -1 and then current column, and that's going to be going up, right? Because if you're in a particular position, you go -1 row, you're going up, and we can just flip that to a plus sign and we're going down. Current row, add 1, you go down. Down. Or we can do -1 to the column. So if you're in a particular column, if you're in a particular column, and then you do -1 to your column, so you go this way, you're going to the left. And then the last is the opposite of this. So if you do +1 to a column, you're moving to the right. If you're right here and then you go column +1, you're going here and you've moved to the right. Okay, so we have this skeleton for the way that this function works. Now we need to fill in the process node step so that we can actually get the island area. So we want to basically increment the island area every time there's a 1. So if we start right here and we go in all 4 directions, when we go to the 0, we don't want to increment the island area. When we go up, we also don't want to increment the island area, and we want to be careful not to go out of bounds. But when we go down here, we do want to increment the island area. So the way I'm going to handle this is I'm going to put some if conditions here. That'll basically skip to the next iteration if anything is invalid, and then at the end, I'm going to increment our island area. So we've seen these conditions before. The very first thing we want to check is make sure our numbers are valid. So we're going to say if current row is less than 0 or current row is greater than or equal to grid.length. You can also, you know what, I'll actually do it that way. We're going to write num rows here, and let's grab these 2 values and just put them at the top here. Doesn't particularly matter, but I prefer it this way. Where did it go? Oh, you know what? I put this here. Okay, and we just want to continue in this case. If the current row is out of bounds, we want to continue. And we want to do the same thing for the column. So we can say if current column, I'm going to use that same shortcut with Command D. So if the current column is less than 0, or the current column is greater than or equal to the number of columns, we continue. The other case is, what if we have a 0? Then, it's valid, but we still want to continue. So we can say if, we can just do grid at current row. Man, I really should just use cur everywhere instead of current sometimes, but that's okay. If the current value is a 0, then we also want to continue. We don't want to add anything to our current island area. If we reach down here, it means we have a valid number and it is a 1. So we can go ahead and say, all right, the current island area is 1 bigger than what we thought it was so far. The important thing here is we don't want to be overcounting things. So we need to make sure that after we process a node, we convert it to a 0 so that it's never processed again. So where in our DFS logic can we modify what we do to every node? Well, that's the process node step. The pop up here and pushing onto the stack, those don't really affect this. But really what we care about is what we do at each node. So the way we'll handle this is we'll just say, after we've bumped our area, let's say that grid at current row and at current column equals 0. So in the future, if we ever do process this location, we will hit line 26. It's important that you check line 26 before you change it, right? Because if we updated this all the way up here, by the way, I'm using Alt up arrow. You can do Alt up arrow and down arrow to move a line in VS Code like this. If we set this value to 0 and then did our checks later, then we're just never going to hit this position for the current row and current column, because we're always setting it to 0, so we're always skipping it. So the order here matters quite a lot. You need to make sure that you are setting this value to be 0 after you check for it. With that being said, I believe this DFS algorithm should be sufficient to get a particular island area, and with that, our getMaxAreaOfIsland function should be complete. Let's go ahead and test it to see if anything was missed. So we can run this. We should get 4. Okay, let's see. Happened from line 50. It said cannot read property 0 of undefined. Okay, line 50. Line 50. Create a row. Sorry, this is not valid syntax. I need to say so long as row is less than the number of rows. Let's see what happens now. Okay, awesome. We get 4, which is the right answer. Okay, let's talk about the complexity of this solution. So R is the number of rows and C is the number of columns. Always make sure to define your variables. We're saying our time complexity is going to be O of R times C, and our space complexity is going to be O of the max of R and C. So our time complexity is R times C. First of all, because of this, clearly there's an R from line 54 and a C from line 55. And we're doing the C for each iteration of this R loop out here, so we get R times C. We also know that our DFS, in the worst case scenario, will touch every node in the graph as exactly once, but it can't do it more than that because we're setting their values to 0, so we'll never visit them again. As a result of that, the upper bound for our time complexity is R times C. For our space complexity, there is no space used here. We just have a finite number of variables that doesn't change based on the input size. Here, our stack, like the maximum size of our stack at any point in time, actually does depend on the size of the input. And you could, in this case, you could go like up, 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 and just continuously push things on the stack. So the height of your input matrix, which is the number of rows you have, is sort of like you can hit that limit on your stack because you just keep pushing upwards. And you can also do the same thing continuously going left. So that's why we say that the max of the number of rows and the number of columns gives us the space complexity. Alright, that's all for this video, and I'll see you in the next one.